Hello, my name is Cole Diamond, and I am presenting my final project for AM207, entitled Collapsed Gibbs Sampler for LDA to classify books by thematic content. And I worked alongside my co-authors Rafael Pesturi and Wei Dai under the mentorship of Rafael Martinez Galarza. So our first step was to get data from Project Gutenberg, and we chose 10 classic novels. Thereafter, we performed pre-processing to normalize our documents with Porter stemming and conversion to lowercase, as well as document sanitization, such as removing stop words and getting rid of frequent intra-document tokens to allow for classification. Now, LDA, or otherwise known as latent Dirichlet allocation, assumes a model where documents are a distribution over topics and topics are a distribution over words. From this plate notation, we can derive the joint distribution, and thereafter we can find the conditional for the latent variable, or the topics, by decomposing this joint and integrating out phi and theta. From that conditional, we can obtain an update step, which we use as our algorithm for performing Gibbs sampling on LDA. Now, to ensure that our algorithm worked, we look at the log likelihood that our model generated our data. We see that this is increasing monotonically and eventually plateaus. We look at a sample statistic, or the number of changes in topic assignment per word across iterations. We see that this is diminishing and plateaus, where correlation is diminishing. And we look at the same custom statistic, but across all of the documents, to see that the swaps in topics are decreasing and plateaus. So here's a visualization of our topic landscape across our 10 books in our trading data. And here's an example of a word cloud produced by our algorithm, where the larger words correspond to higher mass in the distribution of words in a topic. Here's another representation of our topic distribution as a heat map, and another as a bar chart. For prediction, we used the we used the nearest neighbors algorithm, where we computed the L2 norm of our queried distribution against our dictionary. And for each word in this test set, we looked up the argmax according to our model and assigned it that topic. And then from there, we built a distribution over topics. So we were actually able to recover all of the original labels, and we can see that here the local max corresponds to the true label of our test set, which was in order. We also verified the robustness of our model against the number of words in the test set, and this figure demonstrates that. Lastly, we used the generative model to produce a new document from Huck Finn. So that is my final project for AM207. Thank you very much for your time. Goodbye.